Hello dear students, welcome back to this chemistry class. In this video, you will be learning about the electrolysis of aqueous copper sulphate. Please look at the diagram. The anode is made up of copper. The cathode is also made up of copper. The anode is, we know that it is positively charged and the cathode is negatively charged. Right? The electrolyte is acidified copper sulphate solution. That means the copper sulphate solution is taken and it is being acidified with little amount of sulphuric acid, and a 12-volt battery is used, which is connected with an emitter and a rheostat. The rheostat controls the resistance of the circuit, thereby increasing or decreasing the amount of current flowing through the circuit. And the emitter records the amount of current flowing through the circuit. Electrolytic cell, a glass container. Glass container is used as glass is a poor conductor of electricity. Electrolyte, saturated acidified copper sulphate solution acidified with sulphuric acid. The reason the electrolyte is acidified to prevent hydrolysis of copper sulphate and to increase its conductivity. Electrodes, the cathode, copper plate or a rod. Anode, also a copper plate or rod. Temperature, in order to carry out the process of electrolysis, room temperature is maintained because sufficient number of ions are already in the solution. Current, direct current, that is the current obtained from battery, is used of potential difference, that is 12 volt. Magnitude of current is 3 ampere. Dissociation of the electrolyte. Copper sulphate dissociates into copper and sulphate ions. Water dissociates into hydrogen and hydroxyl ions. And sulphuric acid dissociates into hydrogen and sulphate ions. Acidification increases the conductivity and it prevents the hydrolysis of copper sulphate. Electrode reactions. On the passage of electric current, copper ions and hydrogen ions migrate towards the cathode and hydroxyl migrate towards the anode. The reason the ions migrate because negatively charged cathode attracts hydrogen and copper ions and positively charged anode attracts hydroxyl and sulphate ions. Reactions at cathode. Copper 2 plus ions plus 2 electrons gives rise to copper. Cathode is an electron donor. It gives electrons to copper 2 plus ions to form neutral copper atoms. The reason copper ions are deposited on the surface of cathode, whereas hydrogen ions are not discharged. This is due to the low reduction potential of copper ions. Reaction at anode. Cu minus 2 electron gives copper ions. Copper anode itself ionizes to form copper ions which enter into copper sulphate solution. The reason amongst the hydroxyl and sulphate which migrate to anode, none get discharged because the reduction potential of copper anode is far lower than hydroxyl and sulphate ions. The concentration of copper ions in the electrolyte does not change. It is because the number of copper ions discharged at the cathode is equal to the number of copper ions which pass into the solution from the anode. Since the anode is made up of copper and it is an active electrode, and it takes part in the process of electrolysis. Loss in weight of anode is always equal to gain in weight of the cathode. Color of solution: blue. The reason: color of the solution remains unchanged because concentration of copper 2 plus ions in the solution remains the same. Reactions at anode: if anode material is platinum or graphite, that is inert electrodes. Platinum anode: 4 molecules, 4 ions of OH minus 4 electron gives 4 OH. 4 such OH gives oxygen plus water. Oxygen gas is evolved as inert anode is used. Therefore, it does not ionize amongst the hydroxyl and sulfate ions. Hydroxyl ions discharge because they have lower reduction potential than the sulfate ions. My dear students, I hope that you all understood the contents of this video. Thank you all.